Okay, so last class we went over some review for grade 10 concepts, and we'll continue that review. So remember that we did domain and range. Domain is all possible x values, and range is all possible y values. We talked about when there are no limits or restrictions, and that's when you can see an arrow on the end of your line. Now you can have 2 arrows, no arrows, or 1 arrow on your line. Just depending on the location of that arrow, that will tell you what kind of restrictions, if there are any. So here is upper and here is lower. And then we talked about the inequality signs, which you have to be very comfortable with because we're going to be using these a lot in the next couple chapters. So you have greater than or equal to, less than or equal to, greater than or less than. Okay, and there were some examples, and being able to say x is greater than 4 just makes our life easier, because then we don't have to write out x is greater than 4 in actual words. We talked about inclusive and non-inclusive points on a graph, right? So inclusive will be a solid dot, and non-inclusive will be a hollow dot. And if you're writing this out, this would be the greater than or less than equal to, and then the hollow dot would just be greater than or less than. Okay, and that's what that means there. And then we worked with number lines. And so remember, anytime you do domain or range, they each need their own number line, because when you're working in 2 axes, so y and x, you cannot put them both on the same number line because they are in different planes. So you would do a number line for your x and a number line for your y. Okay. Then we did interval notation, right? And so we talked about the square bracket being included values. Okay, so that would be if there is a dot, right? Or if we were told that it was greater than or equal to or less than or equal to. And then the parentheses or the curved brackets meant that that value was not included. Okay, so that would be a hollow dot on the graph or something like that in your notation. And then, of course, that's infinity. Okay, so that's what we did last class, and now let's start what we're going to do this class, and we're going to start with set notation. So this is similar to interval notation, but interval notation only shows the upper and lower limits in the brackets. This method will also tell you what kind of values x and y are. So are they integers, real numbers, natural numbers, irrational numbers, etc. And to use set notation, we have to use curly brackets. Okay, so brackets that look like this. And once again, we have symbols that we'll be using. So you have this funny looking E, and that means that this is something that belongs to or is a member of. And then you have this long line, and that means such that. And we'll be doing examples so you'll understand where in the world we would say something like that. And then over here we have types of numbers. So capital R is all real numbers, capital I integers, capital N is natural numbers, W is whole, Q with a line under it are rational numbers, and then Q are irrational numbers. And it's these first 4 that you're going to see most often. So these are the most common. At this level, you're not going to see irrational numbers or rational numbers that often. So, and this, see your sheet on real numbers, I have a data booklet that I will be giving you guys on Tuesday when you're in class. So how do we write set notation? So an example of a set notation for domain, and remember that domain is our x and range is our y, is So we put our curly bracket and then x, because we're working with domain, x such that, remember that that's our long line, -1 is less than or equal to x, or x is greater than or equal to -1, and x is less than or equal to 10. And this will include all real numbers. So x is a member of, all real numbers. Okay? And here you have your lower limit and your upper limit. Okay, and then this means that x is all real numbers. Oops. Real only has one L. All real numbers between -1 and 10. Okay, so for a generalized one for range, we'll have y such that, put any value in there, y another value, and then just going to erase this part so we have a little bit of room. We'll put y belongs to all real numbers. Oh, and hopefully you caught me there. That's the wrong bracket to put on. We're doing set notation, so we need to put a curly bracket. Okay? And in here, you put whatever number is your upper or lower limit. So let's do this one. Domain. Again, this is x, and this is y. All real numbers between 0 and 10 inclusive. Inclusive is going to tell us which sign to use for the inequalities. All real numbers, that's telling us about r. And here's our lower and upper limit. So we start with our curly bracket, x such that, here's our lower limit. Because it was inclusive, I'm going to use my less than or equal to. Okay, so 0 is less than or equal to x, or x is less than or greater than or equal to 0. And then x is less than or equal to 10, and x belongs to all real numbers. Okay, then for y, do y such that, again, we have between 0 and 20, inclusive, and all real numbers. So x is greater than or equal to 0, less than or equal, and of course this should be y, 20, and y is all real numbers. Okay, and just a quick note, we will not be using infinity when writing set notation. So we use this for interval notation, not set notation. Now, if there is no upper limit, we read what it says, and so if I gave you a set notation of x such that x is greater than or equal to -3, and x is all real numbers, what would we do? First of all, this sign here tells me that it's inclusive, which means that I will put a, what kind of dot? Hopefully you all said solid dot. Now, there's no upper limit. So it's just everything that is greater than or equal to -3. So I will just draw a line, put an arrow on it to show that it's just going to keep going and going and going and going as long as it's greater than that point there. If there is no lower limit, so let's do a range of y such that y is less than or equal to 7, and y is all real numbers. Okay, so We're doing range, so we're on y. It's going to be less than or equal to 7. So again, this is included. We're going to put a solid dot on 7. There's no lower limit, so we will then add our arrow that way with a line. Okay. If we're not given any upper or lower limits, and so remember, if we look at our graph here, here's our arrows, and there's our upper and our lower. So we're saying there's no upper, there's no lower. So here we'll just state, that x and y are all real numbers. Okay, because there's no upper or lower limit. We haven't been given any other boundaries here, so that's what, or restrictions. And to write this in set notation, we'll x such that x belongs to all real numbers. And y such that y is all real numbers. Okay, so right now I'd like you to do the worksheet on set notation. And I'll be doing one more video, so please make sure you watch the second video also before you come to class on Tuesday.